Hi everyone, once again a very good evening to all our viewers out there, all my students here on Zoom. Once again, welcoming you all to this session for physics for JEE and NEET. Welcoming Aanchal, Aliza, Swarada, Tanisha, Vasu. शुरुआत करते हैं आज के सेशन की. We all know we are taking up the topic calorimetry, thermal properties of matter, physics. Let's hit on the target bang on, right? So sharing the screen with all of you, है ना? 1 minute. I think this is YouTube. कहाँ गया? Screen is over here. Okay. Yes. So we'll share it now. Can one of you confirm? So Aryan, screen दिख रहा है clearly?
Yes, sir.
Yes, chalo. Everybody give the first question, है ना? Next question for the day or first question for this session. Question says that once again you are given with a bucket. Bucket again has some water. Bucket again has some water inside it, like this. A coil is put into it. Let us put a heated coil like this. ठीक है. You're again given the amount of water present in this is 1500 grams this time. Amount of water present is 1500 grams this time. You are being told that the geyser that you're using is of 12.6 watts. 12.6 watts. This is the geyser that you use in order to heat this water. ठीक है. You see that temperature rises by 30 degrees Celsius, है ना? You need to again calculate time taken for the same. मैं एक बार दोबारा दोहराता हूँ. I'll repeat the question for all of you. Question says that there is a heating coil of power given in the question as 12.6 watt. You're also being told that there is water which is present inside this, but you're being told one more additional point they have added. They are saying that this heating coil has an efficiency of only 50%. I repeat, this heating coil has an efficiency of only 50%. है ना? 50% efficiency. 50% efficient. That means whatever amount of power they are giving in the question, in reality, only 50% of it gets used to heat up the water. Rest 50% is dissipated. Before it could be supplied to water. आई होप क्वेश्चन क्लियर है. हमारे पास ये जो हीटिंग कॉइल प्रेजेंट है इसका एफिशिएंसी इज ओनली 50%. इसका पावर का वैल्यू इज 12.6 वॉट्स एंड द वाटर विच इज प्रेजेंट इन द tank is 1500 grams. We know specific heat capacity for water already as C is equal to 1 calorie per gram per degree Celsius. We need to go ahead and calculate what will be the time required in which the water will get heated up by 30 डिग्री सेल्सियस. 30 डिग्री से पानी का टेम्परेचर बढ़ने में कितना समय लगेगा अगर हीटिंग कॉइल का पावर इज 12.6 यानी कि 12.6, वाटर प्रेजेंट इज 1500 grams and efficiency of the heating coil is 50%. I will write down the options here on the screen. तब तक everybody go ahead and kindly make the respective calculations in your copies. I hope this time the poll will work. No, it's still not working. No worries. We will start off with the polls here shortly, right? Until then, to koshish karo, go ahead with the same calculation. ठीक है? चलो, everyone. Yes. Yes. Go ahead. Everyone, I'm putting the answers here shortly. The options here shortly. Yes. Dear learners, come on, get going. Simple question. Try karo. Same kind of question. Yes. चलो, your options are here on the screen, है ना? 50 minutes, 5000 minutes, 500 minutes, or none of these. ठीक है, चलो. Go ahead with your polls, everyone. Yes, come on, जल्दी से. You all will have 30 seconds to answer this. Good. Achal, Aliza, Aryan, Makesh, Swarada, Tanisha, Vasu. Come on, get going. I know you all can do it. Come on. Yes. Everybody, go ahead with your polls. Simple question दिया है ताकि हर बच्चा आंसर कर सके. Yes, dear learners, go ahead with your polls. And I know you all can do it. कोशिश करो. Because कोशिश करने वालों की तो हार नहीं होती. है ना? We have to try. लगे रहना पड़ता, तभी सफलता हाथ लगती है. चलो, everybody. Yes. I already have, I think, 4 answers from all of you. Good. Aanchal has given her answer. Tanisha has given it. Okay. Makesh and Aryan. Okay. Others? Yes. Come on, everybody. Okay. Done. Everyone. I'll go for a reverse counter. 5, 4, 3, 2, 1. Chalo, I'll close. Now let's discuss the answer. How many of you could give the answer? Raise your hands. Yes. कितने लोगों का आंसर आ गया? Everybody. Let us see a quick raise of hands from all of you. कितने लोगों का आंसर आ गया? Everybody. Yes. Done, everyone? Chalo, let's discuss this now. So let's discuss it with Aanchal has completed, Makesh, Tanisha. So Makesh, what is your answer? Option number?
Option number D is coming for me, sir.
D. Okay. Tanisha, for you?
Sir, option number C.
C. Then Aanchal, what about you?
Option A.
Option A is coming up. Okay. Aryan?
Sir, option A.
Option A. Okay. So let's see A, C or D. है ना? Aryan, let's solve this with you. Or Makesh, let's solve this with you. Huh? Tell me, how will we go ahead? One by one, step by step. Huh? Yes, Makesh.
Sir, use the formula T equal to Q by P, sir.
So first thing is power is given by heat
Power is
dissipated.
given by 12.6 volts, sir.
Heat given by per unit time, the formula.
Yes,
Right?
sir. Yes.
Work done per unit time. Here, how much work is going in heating the system? 50% or complete work?
50%, sir.
So in this, rather than writing the original power, I will write 50% of 12.6, correct?
Yes, sir.
Okay, which is equal to, work done is heat equal to heat, right? And instead
Yes,
of
sir.
T, let's write time, let's write T. So now T will be heat or Q divided by 1 by 2 of 12.6. This 1 by 2 or this 12 can, this Q can be written as MC delta T, right? Makesh, this 12.6 is watt, है ना? Or
Yes,
joules
sir.
per second. So we can write this as 6.3 joules per second. Now let's substitute the values. How much amount of water is being heated, Makesh?
1,500 grams, sir.
1500 grams. Good. So let's write that 1500 over here. What is the specific heat capacity of water that we know? 1 calorie per
1 calorie per
gram per
per
degree
degree
Celsius.
Celsius.
Yes. And what is the change of temperature that we are looking forward to?
30 degrees Celsius.
30. Let's substitute that. I know. And here are the units in joules or units in calories in the denominator.
Joules, sir.
So do we need to convert it into calories?
Yes, sir. Yes, sir.
Chalo, tell me what's the conversion factor? What's the conversion factor? 4.2 joules is how much calories? 1 calorie.
1 calorie, sir.
So therefore 6.3 joule will be how much calories?
Sir, 1.5 calories, sir.
6.3 into 1 divided by 4.2. Am I correct? Have a check.
Yes, sir.
Okay, let's substitute that here. So here 6.3 will be divided by 4.2 because we want to convert joule per degree per seconds into calorie per second. Sir, reason for this? Reason is the value C that we are substituting over here is in calorie per gram per degree Celsius. Therefore, this also ought to be in calorie, right? With that understanding, let's take this. Okay, so I think this is how much? 7 कितना हो 7 6 42 है ना 7 9 63 and 10 10 already gets cancelled, so we have 3 2s 3 3s correct. Have a look. Yes Makesh, 3 1s 3 10s, this 2 goes to the numerator है ना, so this becomes 2 into 15,000. Have a look.
2 into 15,000.
Which is equal to 30,000 seconds. Have a check. Yes.
Yes, sir.
Let's revise this question. What did we do? We know that power is equal to work done per unit time. This heating coil has an efficiency of 50%. That means out of the total amount of power available, only 50% can be used to heat the water. That is what is happening here. So we have taken 50% of power. This is the amount of heat that is supplied to water divided by time taken. We need to calculate in how much time there is a temperature rise of 30 degrees Celsius. How did we calculate that? We have substituted the values, made T as the subject, which is MC delta T divided by है ना, divided by the power. अभी power का value was in joule per second, we converted, that is watts, we converted into calorie per second. Why? Because C value we are substituting in calorie per gram per degree Celsius, but it is not compulsory. You can also substitute this as 4.2 joule per gram per degree Celsius, है ना? Completely up to us how are we going with the calculations. Everybody quickly put this down into your notes. If this is clear until this point, can I have a raise of hands by everybody here on the screen? अगर हमको यहाँ तक समझ में आ गया, yes, आंचल, अलीजा, Tanisha, Aryan, Makesh, Swarada, Vasu. How many of you are clear with this concept until this point? If not, raise your. If not, just ask me, sir. ये वाला doubt है. If not, if you're clear, just raise your hands quickly. So Tanisha says she's clear. So is Anchal, Swarada, Vasu, Aliza, Aryan, Makesh. Makesh, okay, Makesh is also clear. Okay, Makesh. After this, I want to convert this amount of seconds into minutes. How do I do that? Divided by 60 or multiplied by 60?
Divided by 60, sir.
Divided by 60. So 30,000 divided by 60, right? So this is, I think, 6 5s are 30, right? So 500 minutes should be the correct answer. Am I correct? Have a look.
Yes, sir. Yes, sir.
500 minutes is the right answer. How many of you could get to the right answer along with me? After you're done writing this calculation, these 5 steps into your copies, go ahead and bring your hands down. जैसे ही सबका आंसर मेरे साथ साथ आपकी अपनी अपनी कॉपीज में आ जाता है, अपना hands down करना. Everybody who is watching us there via YouTube, आप भी बता सकते हो. सर वी आर डन. सो ग्रेट. आंचल हैज कंप्लीटेड. सो हैज आर्यन, मकेश, स्वरदा, तनीषा. गुड 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 गुड. ओके, सुपर. अच्छा, जिन लोगों की गलतियां हुई थी, आई होप यू ऑल हैव करेक्टेड. इफ एनीबडी हैड डन एनी मिस्टेक, प्लीज गो अहेड एंड करेक्ट द सेम. ऑल राइट, डन एवरीबडी. लेट्स टेक द नेक्स्ट part of this chapter. So abhi we all have understood how does what is happening here in this question. ठीक है, how is heat transfer etc is happening. Let's take one more question. ठीक है, this kind of question says that, or first write a principle that heat exchange. Abhi suppose we learned one principle that suppose we have two bodies. I will make one with suppose red in color, which is giving out heat, and another one let's make with blue in color, which is absorbing heat, the cold body. Suppose you have two bodies. We have just learned the principle that the heat will flow from a body at high temperature to a body at low temperature. Now, is this statement correct? Anchal, what do you think? The heat flows from a body at high temperature to a body at low temperature. Are we correct when we say that? Okay. Now that the heat is flowing in this direction as shown on the screen, my next agenda would be to make you all understand कि heat flow कब तक चलेगा. When will this conventional heat flow direction be maintained? तो fundamentals ये कहते हैं कि heat flow will keep taking place until temperature becomes same in the two bodies. I repeat, जब तक दोनों bodies का temperature same नहीं हो जाता, तब तक हीट का इवोल्यूशन होता रहेगा फ्रॉम बॉडी 1 टू बॉडी 2. प्लीज मार्क दैट इन दिस सिस्टम वी आर अज्यूमिंग दैट देयर इज वैक्यूम आउटसाइड दिस. इसके आसपास देयर इज वैक्यूम. वैक्यूम का प्रेजेंस मीन्स दैट देयर इज नो लॉस ऑफ हीट बाय कंडक्शन और कन्वेक्शन. यस, रेडिएशन का हीट लॉस टेक्स प्लेस, बट वी आर assuming that that is not happening right now or it's equal to zero. Okay, we are not concerned with it right now. Suppose I want to ask you all, can you calculate what is the amount of heat that is lost by the hot body? You will say, sir, definitely if the hot body is losing all its heat to the cold body, so ultimately the heat lost by hot body is equal to the heat gained by the cold body. I will repeat my words. Until then, please quickly draw the diagram and put this into your copies, dear learners. Heat lost by hot body is equal to heat gained by cold bodies. I repeat, heat lost by hot body is equal to the heat gained by cold body. This is called as principle of calorimetry. यही कहलाता है कैलोरीमेट्री का प्रिंसिपल. कोई भी दो बॉडीज के बीच में, any two bodies which are undergoing a heat transfer, one is losing, other is gaining. Because of temperature difference, heat transfer will keep taking place. First bonus point, everyone. Heat transfer will keep taking place until both bodies attain a same temperature or common temperature. I repeat, heat transfer will takes place until when? Until heat transfer happens. Transfer till what time? Till when? So it will happen till both bodies have common or same temperature. Till both bodies attain same temperature. So this is one principle that we all need to remember in order to solve these kind of questions. Next principle that will help us, that whatever heat is being lost by the hot body is the same amount of heat gained by the cold body. Heat lost by the hot body is equal to the heat gained by the cold body. Please remember, डू नॉट प्ले विद द साइंस हियर. साइन यानी कि प्लस या माइनस के साथ खेलने की जरूरत नहीं है. बी वेरी क्लियर एंड क्रिस्टल, लाइक कीप दैट क्रिस्टल क्लैरिटी इन योर माइंड. कैसे करना है? हैव अ लुक हियर. सपोज बोथ बॉडीज हैव मासेस m1 m2 respectively, specific heat capacity as c1 c2 respectively, and let's take their common temperature to be T. मतलब थोड़ी देर के बाद ये पूरा का पूरा system, that is the first block and the second block, let us say both of them come to the same common temperature T. If both have the same common temperature T, let us write down this principle of calorimetry. If you want to write this in your copies, please write it here. This is principle of calorimetry. Principle of calorimetry. Right? Principle of calorimetry. अभी इसी principle को we all are studying here, है ना? तो अभी let's take this with Aliza. Aliza, जो common temperature है ना? जो common temperature है, can you tell me, will it be greater than T1 or less than T1?
Sir, it will be less than T1.
Why? Why less than T1?
Sir, because T1 और T2 के बीच में ही होगा ना जो भी temperature.
Yes. So we all need to understand that the final common temperature will lie between T1 and T2. T2 से कम नहीं हो सकता, T1 से ज़्यादा नहीं हो सकता. So you all can write this expression also. The final temperature, this is the final temperature, है ना? This final temperature will lie between or will be less than T1 and greater than T2. By this logic, we can write something else also in the final expression. So Aliza, therefore, what will be the expression for, अच्छा, what is the general expression for heat? क्या होता है Aliza? Q is equal to mc delta T. So can I write Q is equal to m1 c1 delta T1, correct?
Yes.
And similarly, what will be the expression for the heat gained by the cold body?
Delta T2.
M2 C2 delta T2. Let us expand it further, but be cautious. We want to be positive on both sides. दोनों तरफ ऐसा नहीं हो, एक तरफ हम वैल्यू को पॉजिटिव कर रहे हैं, दूसरी तरफ नेगेटिव. प्लीज बी कॉशियस एंड राइट सच एक्सप्रेशंस दैट यू आर टेकिंग द मैग्नीट्यूड ऑफ हीट, नॉट जस्ट द साइन इन बिटवीन. ठीक है? सो अभी आर्यन, लेट्स टेक दिस विथ यू. So Aryan, as we just discussed that first वाला body is becoming colder, तो इसका initial temperature T1 higher या T2 higher?
Sir, T1.
T1. So can I write it reaches from T1 to T2 like this? T1 minus T is the
Yes,
change
sir.
in temperature. Acha, for the second body, tell me which one is greater, T or T2?
Sir, T.
So will I write T2 minus T or T minus T2?
Sir, T minus T2.
T minus T2. This is the only difference that you need to maintain as you are going for the substitution. Of course, this delta sign otherwise always means final minus initial. लेकिन यहाँ पर we are concerned with the magnitude. So if you want, you can put this sign also. ठीक है? We are concerned with the magnitude and not the signs. So please make sure that the heat value that you're putting on both sides is substituted in a manner so that always the higher temperature will come in front and then the lower temperature, फिर वो कैसा भी हो, right? So we know for the first combination T1 is higher, for the second combination T is higher than T2. Put this into your copies and then let's practice. Once you all are done writing this into your copies, let's take up questions based on this. Once you're done, let me know by a raise of hands. Go ahead, dear learners. Yes, come on, quickly. जैसे ही हो जाता है, you all will let me know, sir, we are done writing. Kindly, let's move ahead. Come on, everybody. Yes. Raise your hands, okay? I'll wait for all of you, dear learners. Done? Okay. Abhi, let's proceed to the next question. Everybody, है ना? Chalo. Everyone, let's have this question on the screen. ठीक है? You are being given there are two bodies, right? Mass of one is double that of the other. I repeat, एक का mass दूसरे का double है. This is what the question says. So mass of the first body, this is suppose first body, this is second body. Question says that mass of one is double the other, double the other. Okay, then next one is specific heat capacity of the second body is equal to 3 times the specific heat capacity of the first body. This is the second data given. Question says that initially both bodies have temperatures 100. This one has a temperature of 100 degrees Celsius. This one has a temperature of 20 degrees Celsius. है ना? You need to calculate the common temperature. मैं repeat करता हूँ. Everybody question. Listen to it carefully. You are being given there are two bodies. Mass of body number 1 is double the mass of the second body. Now for the second body, specific heat capacity is 3 times that of the first body. The first one has an initial temperature of 100 while the second one has an initial temperature of 20. You need to calculate what will be the common temperature. I will write down the options here on the screen. You all can go ahead with your calculations, dear learners. Come on. Yes, chalo. Jaldi se each one of you will go ahead with your calculations and let me know once you all are done by a quick bringing of hands down. अपने हाथ नीचे ले आना once you all are done writing. Yes, dear learners, go ahead. Come on, quickly. Yes. Swarada, you'll have to answer this, so be prepared. Yes, chalo. Everybody, go ahead. Come on. Keep going, everybody. I hope you all are ready. Simple question. Here are your options on the screen. Writing them quickly. Over to you, everybody. 104 degrees Celsius. ठीक है. 42 degrees Celsius, 26 degrees Celsius, or 52 degrees Celsius. है ना? If you're not getting any of these, you can send me none. Yes, your time starts now. You can send me the options by chat. Chalo, everybody. Yes, go ahead quickly. Come on. Okay, take 20 more seconds. Good. So Aanchal has answered it. So has Aliza, Aryan. Good. Many of you have answered it correctly. Very good. All three of you, in fact, answered correctly. So let's take 15 more seconds, dear learners. 10 more seconds to go. Okay. 5, 4, 3, 2, and 1. Closing the poll, है ना? Now, okay. Tanisha, Aryan, Aliza, Aanchal, and Aryan. Okay, chalo, great. So those who could answer it, can I have a quick raise? Okay, can I have good bringing of hands down by those who could answer it? Yes, so Aanchal could answer it. Okay. Aliza, Tanisha, all right, Aryan, है ना? Swarada, let's discuss this with you as we had said. चलो, कैसे करेंगे Swarada? What will be the approach? हाँ.
Sir, I tried to substitute it into the formula M1 C1.
And that's the correct approach. Absolutely correct. Yes.
So we're given that C2 is thrice
1
of
second.
C1.
1 second. 1 second. 1 second. So something is happening to the screen here. Can you all see the screen, by the way? Is everything written in front of you? Yeah, is it rubbed?
It's slowly appearing.
Okay, it's slowly
And
up. Yes.
as if it was rubbed and you're drawing it again.
Yeah. So let's put it here. Okay. Okay. My PC plays hide and seek with me nowadays. Why? Chalo. So I think this was the data, right? Am I correct? Surada, see, is there any other data missing? No, right? Everything is here. Chalo. Yes, Surada, read it out. Go ahead. So what was given?
Yes, so we were given that
there are two
C2 is thrice of C1 and M2 is twice of M1.
Which means that relationship between their masses and specific heat capacity was given. We know, suppose,
Yes.
let us assume that the final temperature is equal to how much? Let's assume it's equal to T. है ना? Okay.
Yeah.
So
Yes,
what
T.
can we write? The idea is the T will lie
M1,
between
the two temperatures, 120.
so 120. Let's write that also. ठीक है, Swarada, correct? Acha.
Yes.
What is the other funda that we need to keep in mind? That whatever, according to the principle of calorimetry, whatever heat
It will
will
be
be
less
lost
than
by.
100, but more than. Oh
No.
yeah, it will, the heat lost by the first object will be heat gained by the second object.
So heat gained and heat lost will be equal to each other.
Equal.
So let's write heat loss is equal to heat gain. Okay. Now, in order to write that expression, what will we write? M1 C1 delta
C1
T1 is equal to
M2 C2 delta T2.
Okay. Now, what is the M1 value? Question says that mass of one is double the mass of the other. That means if the
M2
mass of
by
2 is
2.
M, this is equal to 2M. Correct? Right?
Yes.
Okay. Then second one ka heat capacity is 3 times the first one. So if first one is C, this is 3C. Right?
Yes.
Okay. Then since the initial temperature of the first body is 100 degrees Celsius, its final is T, है ना? And we want to
100
write
minus
higher
T.
minus low. Very good. 100 minus T. Let's substitute that also. So 1 minute. Chalo. So we will have 100 minus T. Okay. Then on the other side, क्या होगा? Tell me. अभी
It
अगले
will be
side
T
में
minus 20.
T minus 20. Why? Because T is greater than 20. Simple.
Yes.
Let's make the respective calculations on both sides. So M and C get cancelled. We'll have 200 minus 2T
Minus 2T
is equal
is
to
equal
3T
to
minus
T
60.
minus.
3T
Yes.
minus 60, right? On multiplying the numbers respectively. Now this minus 2T will go to the other side and become plus. This will
Plus
also go to
5T.
the other side and will become plus.
Minus.
Plus,
Oh,
minus.
sorry, plus, yes.
Plus. So 200 plus 60, and there we'll have 3t plus 2t, which becomes 5t is equal to how much? 260. And
60.
therefore, what is t equal to? T is equal to
260 by 5.
5. So 260 by 5 है ना. अभी what is 260 by 5? Suppose if we don't know, multiply numerator denominator by 2. Now 260 into 2 we can easily calculate as 520 divided by 10 is 52 degree Celsius. Easy? Yes, चलो let's quickly discuss this everybody. है ना, एक बार देख लो if you all want. अभी हमने क्या किया था? You are given two different objects, their respective temperatures and specific heat capacities and masses का relation was there in the question. We were told that what will be the common temperature of the two bodies. What did we do? Heat lost by the hot body is equal to the heat gained by the colder body. Simple funda, m1 c1 delta t1 is equal to m2 c2 delta t2, but keeping in mind that you are keeping entire term positive, no exchange of variables in a manner that you confused with the signs. ठीक है, तो हमेशा full value remains positive because we are concerned with the amount of heat, not the sign. So that amount of heat that is being lost by the body which is getting cold, which is cooling from 100 to T degree Celsius, and this getting this second body which had a temperature of 20 is getting warmed up to T degree Celsius. This simple fundamental we applied in this question to reach our final answer, where the final T comes out to be 52 degrees Celsius. Entire calculation in front of you. Which option is correct, Swarada? Option number D, है ना? चलो, everybody quickly put this down into your copies. Once you all are clear, first if you all are clear, raise your hands. अगर हमें clear है, समझ में आ गया सर, ऐसे आगे बढ़े. This is how we moved ahead. A raise of hand. Okay, a raise of hand from each one of you. अगर हमें समझ में आ गया, if we are clear, so this is how we have moved ahead. Once you all are done writing this into your copies, bring your hands down. Yes, चलो, everybody. Once you all are done writing this into your copies, will bring their hands down. Yes, dear learners, come on. Come on, come on, come on. Yes, everybody. Done. Okay, superb. Everybody, सबका हो गया इतना जल्दी? Good. Everybody, very good. Aliza has completed. Aryan, Swarada, Tanisha, Vasu, very good, very good. Chalo, chalo, everybody, come on. Do this. You know. Done? Okay. Achal, let me know. Have you completed? Makesh, we're moving to the next question. Be quick, right? So here is your next question coming up on the screen. ठीक है, चलो. अभी ना, let me introduce you all to one more fundamental, है ना? To one more fundamental, which is called simply thermal capacity or heat capacity. We just learned specific heat capacity, no? Now there is a similar term called as heat or thermal capacity. Heat or simply thermal capacity. Everybody will write this into their copies. Heat or thermal capacity. तो अभी ये हीट या थर्मल कैपेसिटी और थर्मल कैपेसिटी में क्या फर्क है? सपोज आई विल रिप्रेजेंट दिस हीट. अभी ना देर आर डिफरेंट वेरिएबल्स एक्चुअली विच आर यूज टू रिप्रेजेंट दीज इन डिफरेंट कॉपीज. ठीक है, वी कैन यूज, यू कैन यूज वॉट एवर यू लाइक, राइट? सो सपोज आई विल रिप्रेजेंट this by capital C, suppose, है ना, and that specific heat capacity by small c. Specific, just writing them side by side for your clarity purpose. Specific heat capacity, let me represent it by small c, and the heat capacity value by capital C. तो इसका relationship क्या? Understand this, okay? So heat value can be either written as m into, similarly here also I'll write m into, ठीक है, c times of m into c times of delta t, or simply c into delta t, or simply capital C into delta t. So Aryan, by using this equation, what can we understand कि capital C और mc में क्या relation है? If I am writing the expressions like this, Aryan, can we write that first?
The heat capacity is independent of mass.
No, यहाँ पे इससे relation बताओ. C is equal to Q by
Delta T.
delta T, और यहाँ से specific heat capacity is Q by M delta T, है ना? Good. So this basically brings us to at least one factor, and that factor is heat capacity का unit कैसा होगा? Yes, SI unit for thermal capacity will be, Aryan?
Sir, joule per Kelvin.
joule per Kelvin or simply joule per degree Celsius. Similarly, what will be the SI unit for specific heat capacity, Aryan?
Sir, joule per kilogram day per Celsius.
हाँ, joule per kg per Kelvin or joule per kg per degree Celsius. Easy? Yes. So I hope
Yes,
you
sir.
will at least get the mathematical construct that I was trying to illustrate. Each one of you will put this down into your copies. Let's take some questions and make it even better. है ना? I'll repeat for all of you. Thermal capacity is just a simple expression which is equal to mass into specific heat capacity. So ये जो specific heat capacity होती है ना, ये body की property होती है, right? It is the property of the body. Whereas this thermal capacity will be different for different masses. अगर आपने 1 किलो का कोई suppose iron ले लिया, so 1 kg of iron will have a different thermal capacity than 100 kg of iron, right? It will have a different or a factor multiplication of 100 का difference. अभी this is what the logic is. This is the property of the body. This is the property of the body. Of course, this C value can not change with temperature, but that we are not reading right now. It is completely out of the context currently. But it is the property of the body, whereas this one depends on mass. This one depends on mass. The more is the mass, the more will be thermal capacity. See, by the name itself it is clear. Thermal capacity यानी कि heat धारण करने की क्षमता, right? Heat धारण करने की क्षमता or the capacity to behold or capacity to hold heat within itself. So, if a substance can hold large, also actually hold is not a proper word for heat. Heat is always in transit, okay? So, whatever heat can be supplied to a given substance, right? If that value is very large, for a small rise in temperature, for a very small rise in temperature, if I can supply huge amount of heat, then I will say there is a large heat capacity. Okay? There is no context of mass in this question. Chalo, everybody will put this into their copies. Yes, dear learners, come on, quickly. Yes. So heat capacity depends on mass, whereas this is the property of the body and does not depend on the mass. This second thing does not depend on the mass. Yes, dear learners, go ahead. Does not depend on mass. जैसे ही हो जाएगा ना, everybody will let me know units, their formulas, etc., their relation, है ना? I've written everything on the screen. Once you all are done writing, you all will raise your hands. हाँ सर मेरा हो गया, so that we'll proceed. हाँ चलो, everybody, come on, go ahead with your calculation and let me know by signaling. By raising your hands. Okay, Aliza has completed. Good. Okay. Then we have Tanisha and Aryan have also completed. Anchal, Makesh, Swarada and Vasu. Once you're done, let me know. Dear learners, go ahead. Yes. So I'll give a question to all of you. Okay? I'll give a question to all of you. Here is the question coming up. Okay? Get ready, everybody. I'll go for a reverse counter. Done? Okay. Swarada, Vasu. Yes, quick. 5, 4.
Done. My hand is not.
Okay. Yes, Vasu, maybe take a screenshot. 5, 4, 3, 2, 1. है ना? Let's take a question. So suppose, what's the value, Tanisha, of specific heat capacity of water?
Sir, 1.
1 what?
1 joule per gram.
1 calorie. 1
1
calorie
calorie.
per gram per degree Celsius.
Celsius.
Right? Okay, and in joule, tell me. 1 calorie is how many joules?
4.2.
2 joules. So in joules, what will be the value of specific heat capacity, Tanisha? 4.2 joule per gram
Joules per gram per degree Celsius.
Celsius. Chalo, good. Now I ask you, suppose you all know specific heat capacity value, or CW for water is known to you all as 4.2 joule per gram per degree Celsius or per Kelvin. I ask you something. I ask you, what is the thermal capacity? I ask you, what is the thermal capacity of 30 grams of water? Suppose you need to calculate thermal capacity of 30 grams of water. Simple question, and everybody can solve it. I will write down the options here on the screen. All of you at least attempt, and I'm sure you all can do it. You all know the relation. Okay? You all just need to substitute the values. So 30, है ना? Your options are 621, 126 or 252 और none. ठीक है, in joule per degree Celsius or joule per Kelvin. Anything is the correct unit. That is why I'm writing different units. So all units are correct. Come on. Your time starts now. Go ahead with your polls. Yes, you can put down your answers in the chat box. Go ahead, everybody. Yes. You can put down your answers in the chat box, everyone, and bring your hands down once you're done answering. है ना? So we have started with the polls. Take not more than 30 seconds. Yes, 20 more to go. Okay, Praveen, Tanisha and Achal have given their answers and I think all of them are doing it correctly. Makesh will also answer it correctly. Makesh, you will have to answer this question, okay? Chalo. Good, good, good. Vasu, would you want to try? Would you want to try this question with me, Vasu? Okay, 5 more seconds to go. 5, 4, 3, 2, 1. है ना? Let's solve this along with Vasu. Vasu, tell me what's the relationship between thermal capacity and specific heat capacity, Vasu? What's the relation? Capital C is equal to? Capital C is equal to?
MC.
M into small c. Once again, what is capital C equal to, Vasu? M into small c. Okay, so let's substitute the values. Abhi thermal capacity ka value is equal to mass into specific heat capacity, correct? What is the mass value given to us, Vasu? 30 grams. And what is the value for specific heat capacity known to us, Vasu? Here, Vasu. 4.2. है ना? Joule per gram per degree Celsius. Let's cancel out gram on both sides. Now 4.2 into 30 है ना? Joule per degree Celsius or per Kelvin, correct? So abhi because of the 0, this point will go ahead and or will get removed. 42 into 3. Tell me what is 42 into 3? Yes, Vasu. 40 into 3 is 120 and 2 into 3 is 6. So 126 joule per Kelvin or joule per degree Celsius. Is this clear, Vasu?
Yes, sir.
Okay, can you explain this to everybody? Over to you, Vasu. Yes, in 1 minute. Yes, Vasu.
So the equation for finding out thermal capacity of water is capital C is equal to M into small c, which is equal when the given grams we have is 30.
Yes, chalo. Good. I hope everybody is clear. Please take a screenshot. If anybody is remaining, go ahead. 5, 4, 3, 2, 1. Chalo. I hope everybody is done. Okay? Now we are talking about one more concept which is called as latent heat. Everybody will write this in their copies. Latent heat. Sir, ये क्या होती है? And what is latent heat? Let's talk about it. तो क्या होता है in substances like all three states of matter, ठीक है? There are heat का use matter दो तरीके से करता है. The heat is used in two ways by matter. One of the ways is to increase the temperature. Heat के दो प्रकार के usage हो सकते हैं. Heat का first usage is to increase the temperature, to increase or decrease the temperature. मतलब if you supply the heat, the temperature will increase. Of course, if you will remove the heat, the temperature will decrease. This is one usage of heat, है ना? This kind of heat is called as sensitive heat. Sensitive heat. ये heat is responsible for the change of temperature. Sensitive heat is responsible for change of temperature. ठीक है? It brings about a change in the temperature. ये change लाने का काम करता है, right? But the state does not change या phase does not change. Phase या state means solid, liquid and gas. ठीक है? The phase or state of matter does not change. Only temperature changes, does not change. ठीक है? This is what happens when there is a sensitive heat ka concept. But heat is used for one more purpose, and that purpose is to change the temperature of the substance. We all know if we talk about solids, liquids and gases, तो solids के अंदर, so Aanchal, all the molecules are tightly packed or are they loosely bound?
Tightly packed.
Tightly packed. And what about liquids? Are they relatively freer or more packed even?
They are relatively free.
Okay, they're relatively more free. Great. Acha, what about gases, Aanchal? Are they still more free or they are more compact than the liquid?
They are more loose and free.
They're more loose and free and they're very far away. This is what the concept of solid, liquid and gas is all about. This is where another kind of heat comes into play. Its name is latent heat. Latent heat एक ऐसी heat है. It's written as LATENT. Latent heat is that heat which is required to change the state of a substance. इसका purpose क्या होता है? So basically we all know that solids में molecules are closer to each other because of intermolecular forces of attraction. Molecules एक दूसरे को attract करके पास में बंधे हुए हैं, है ना? And this force gets broken up by something called as latent heat. जब आप बाहर से खास तरह की heat देते हो, actually there is no specific heat. ऐसा नहीं होगा कि latent heat के लिए गैस पे रखना है और sensitive heat के लिए कोल पे रखना है. No, coal and gas temperature both will give the same amount of heat. It is up to the substance. How does it use that heat, whether in the form of latent or sensitive? We'll shortly get that idea, but just write this into your copies that latent heat is that heat which is required to change the temperature, है ना? It can be either ways. So the funda is, if any substance goes from solid to liquid, it's called melting or fusion. है ना? And the reverse is also true. मतलब if any substance goes from liquid to solid, it's called solidification or freezing. ठीक है? This is solidifying or freezing. Similarly, if a substance goes from liquid to gas, then it is called as boiling. Or vaporization. Not evaporation, okay? Evaporation is a different process. It takes place at all temperatures, है ना? Evaporation is a very different process. This is not evaporation. This is vaporization. Evaporation is that process जो मम्मी जब बाहर कपड़ों को सुखाने डालती है, right? When in our homes we dry the cloths on the wires. So what happens with those cloths? Those get dried due to evaporation. So the cloths which we are drying in our courtyard, those cloths are being evaporated. Their water is being evaporated from the cloths. Whereas this is not evaporation. This is vaporization. है ना? Vapor, VAPORI or either POU. Just check it on the internet. Vaporization. ठीक है? Alright. Then similarly, I think it is POR, okay? Vaporization, or you can just check. And the other one is from gas to liquid is called condensation. Gas to liquid is called condensation or liquefaction. Liquefaction. Also, please be clear with these spellings. You can check them over the internet, right? Liquefaction. Similarly, here we have solidification. Okay? Right, pardon me for the spellings here if I'm going wrong anywhere, right? Solidification. All right, so I'll get the basic notion correct to you all. See here, we have, I'll repeat it for everybody. The fundamental is heat का प्रयोग दो तरीके से हो सकता है. The heat can be used in two different ways by any solid body or liquids, right? First is sensitive heat is that heat which is required to change the temperature of the body, whereas latent heat is that heat which is required to change the state of the body. So it's responsible for, so this latent heat is responsible for, this latent heat is responsible for change of phase or state of matter. Okay, state of matter. But please remember, whenever the state or phase of matter is being changed, no, at that time temperature नहीं बदलता है. ठीक है? At constant temperature, यानी कि सॉलिड, लिक्विड या गैस जब कन्वर्ट हो रहे होते हैं, फॉर एग्जाम्पल व्हेन आइस इज मेल्टिंग, राइट? व्हेन आइस इज मेल्टिंग, एट दैट मोमेंट ऑफ टाइम द वाटर सराउंडिंग आइस एंड आइस विल बी एट 0 डिग्री सेल्सियस ओनली. मैं रिपीट करता हूं, वॉट एवर प्रोसेसेस दैट वी आर टॉकिंग अबाउट हियर, दैट इज द फेज चेंज प्रोसेसेस, दीज ऑल प्रोसेसेस आर हैपनिंग एट कॉन्स्टेंट टेम्परेचर. मतलब ड्यूरिंग द स्टेट का चेंज or solid to liquid, liquid to gas, gas to liquid, liquid to solid, whatever change that we are taking into consideration, the value of temperature remains same or does not change. Please remember, these processes are constant temperature process. मतलब जब ice पिघल रही होती है, for example, its temperature is not going to change and it will remain at 0 degree Celsius. I'll just write something down here. जैसे in case of we just read about latent heat, or just we read about specific heat capacity and thermal capacity. Similarly, there is one more capacity of the substance which is called latent heat capacity. You all understood what is latent heat, hai na? There is one more funda called as latent heat capacity. Everybody will write this down. Latent heat capacity. Latent heat capacity. Okay? Capacity. There are different ways to represent it. One common way is writing it by L, because L is very convenient. Okay, so this latent heat capacity कैसे define करते हैं? If suppose latent heat is given by Q, okay, right? Latent heat or heat required for phase change. Heat required for phase change. Okay, for phase change. Now the heat Q is equal to m into L, क्योंकि टेम्परेचर का चेंज तो होना ही नहीं है, राइट? नो चेंज ऑफ टेम्परेचर इज गोइंग टू टेक प्लेस, सो डेल्टा टी इज नॉट देयर. mc डेल्टा टी होता था, सो इंस्टेड ऑफ c आई एम पुटिंग L, बट देयर इज नो डेल्टा टी हियर बिकॉज व्हेन द हीट का एक्सचेंज इज हैपनिंग एट कांस्टेंट टेम्परेचर, सो टेम्परेचर इज कांस्टेंट, डेफिनेटली तो यहाँ डेल्टा टी नहीं आता. सो हियर दिस m is mass, this q is the latent heat, or the heat that is causing a change of phase. Body ka phase is changing, or the state of matter is changing. So this is latent heat, and here we have latent heat capacity L. ठीक है? A basic idea I'll give you all, or let's take this in the coming class. ठीक है? इसको और practice करते हैं. I just wanted to give one idea, but ठीक है, just write it down in your copies. Take a screenshot. 5, 4, 3, 2, 1. ठीक है? Understand this. Just take a screenshot if you all want. So just letting you all understand something, इसको sync करने देना mind में, ठीक है? And if possible, read HC Verma before you're coming to the next class. Read HC Verma before you're coming to the next class. Also, I've sent you all certain assignments. मैंने आप लोगों को कुछ assignments भेजे हैं. Please make sure that you are finishing your assignments and sending them to me back in time. See, just writing down this last statement for the day. Suppose you start heating ice, okay, which is at say minus 20 degrees Celsius. So how is heat utilized? मैंने कहा था ना, how does the substance decide कि उसको latent heat चाहिए कि अभी आपको specific heat चाहिए? So see, this is what has happened. So ice का temperature will first start rising. So here sensitive heat will be used. Okay, like ice का temperature will start rising and become, say, ice at 0 degrees Celsius. When it reaches 0, at this point it will absorb latent heat and convert into water at 0 degrees Celsius. After this, again, the water will start heating up and will change into water at whatever given amount of value that you are writing. So I'll rub this. Okay. Say water will change to some given value, say 30 degrees Celsius or whatever you want. You make those calculations, okay? Now suppose water is further getting heated up, okay? Say to water at 100 degrees Celsius. And then ultimately here, the latent heat of vaporization will come into play. So of course, latent heat has two types. One which is involved in this phase change, liquid solid liquid, liquid solid, and the other is latent heat between liquid gas or gas liquid. Okay, so next one will be water at 100 degrees Celsius changes to steam at 100 degrees Celsius. Now this steam will further get heated up to suppose steam at 120 degrees Celsius, है ना? So this is how the temperature का or phase का variation happens. Here sensitive heat, here latent heat again used, here again sensitive heat, here also sensitive heat, here latent heat because phase का change is happening, and then again sensitive heat. बहुत प्यारा topic है. There is a lot I want to teach you all, but let's continue in the coming class. We have good amount of time in our hands. Let's continue, dear learners. अपना ख्याल रखिए, अपनों का ख्याल रखिए. Thank you everybody. If there is any doubt that anybody would like to discuss, I'm there for all of you. Until then, goodbye. Or if you all can allow, let's discuss in the next class itself. I hope कुछ बच्चों ने कुछ doubts भेजे, but I need to actually sleep early today for some reason. So I hope you don't mind if we can clear your doubts on the coming Saturday. Please let me know कि sir Saturday को class रखिए. I always wait until Friday evening so that you all can put up your queries कि sir please tomorrow I want a class. So I'll reserve those slot for all of you, right? Tomorrow also I can take a class for all of you if you all are available at what time? Between 5 to 6. Between 5 to 6, if anybody wants a class, please put a message to me in advance by or tomorrow let it go. I will keep my Unacademy class. Let's keep it on Saturday only, as we are fixed Saturday को in the afternoon. ठीक है, चलो. Okay then. Bye bye everybody. Take care. Or we can also keep it between the time 8 to 8:30. Someday if you're starting the class early at 7 and I find that syllabus आज के लिए काफ़ी हो गया, we might take it up on the next class. So next class, let's continue this. But please make sure that you all are reading from HC Verma. Write it in your copy. HC Verma assignment. HC Verma reading of the calorimeter concept. ठीक है? Sure. Bye everyone. Take care. Good
Yes,
night.
sir. Thank you, sir.
Yeah. Take care. So those of you who are watching me over YouTube, I hope you're enjoying these sessions और हर क्लास में आपको कुछ ना कुछ सीखने का मौका मिल रहा है ना. हम लोग इन्हीं सेशंस को आगे भी कंटिन्यू रखेंगे. हर सेशन में अपना लर्निंग का कर्व ऊपर लेके जाते जाना है. बस मेहनत करते रहना है, कोशिश करते रहना है कि क्योंकि जो जीतते वही हैं जो लगे रहते हैं, है ना. आई रिपीट, जीतते वही हैं जो लगे रहते हैं. अपनी स्ट्रैटेजी है ना, अपने से जितना हम लगा सकते हैं वो लगाना है, बाकी गॉड के ऊपर छोड़ना है. जितना अपन अपने काम पे ध्यान रहते हैं और जितना रिजल्ट को यूनिवर्स पे छोड़ते हैं, उतना मन भी शांत रहता है और काम भी अच्छे से होते हैं. With that positive message, this is Khushwant Fatnani letting you all know that if you would like to be a part of my classes, the fees per month is rupees 3,000. The classes are held on Tuesday, Thursday and Saturday, that is TTS for class 11th, and Monday, Wednesday and Friday for class 12th. You can get to know which chapter I'm currently dealing with in both the classes, in both the batches, by going to my playlist section. Okay, you can also find me on Unacademy. Just go and type Khushwant Fatnani on your Unacademy app and you can find my profile there, because I have my classes in the daytime at Unacademy. Here I take my classes in the evening. Goodbye everyone. Take care. This is Khushwant Fatnani giving you all a great namaskar and Shubhratri.
Thank you, sir.
Good night. Thank you, Vasu.